Hi everyone, welcome to CS50 Week 7 sections. My name is Yulia and today we're going to talk about SQL. I'm a preceptor here on Harvard's campus, help us run the college class as well as everything that we do online. And today we are diving into SQL, which is a language to manage databases that is really used widely across industry as well, including our problem sets this week and the finance problem set that is going to wait for you in a couple of weeks, and it's something that is also really helpful for the final projects if you are looking to manage vast amount of data. But on agenda today, we're going to talk about databases, how to design them well, what attributes are important, and as well as we're going to dive into the songs problem set to really just get practice of how to write queries and how to access that information. But let's get going and let's talk about design principles first, right? Like, what does it take to have a good database? Well, first one is that each table should be a collection of a single entity, right? We should have different tables for different kind of information just so that we can separate it and access it easier. For example, here we have two tables that contain some employee information, right? But not just congregated in one. You might have just a general table that has the name and the role of your employees, and also the employee relationships table where you record those interactions or relationships, for example, in your workplace, right? Instead of, combining it all in one table and maybe having multiple rows, repeat information, or multiple columns, repeat information, that's not super efficient. The second principle that we're going to talk about today is each piece of data should be stored in a single location, and then it should be referred to by its ID. For example, if we take a look at our database again, and let's go back to the one we just saw, we are recording the relationship using name Laura and Alice. But what happens if there is another Laura or another Alice that just have different last names? Well, it would be better to assign everyone a unique ID so that we, as well as the computer, knows that there is only one person with a specific ID that is unique that we associated with. And in such a way, we don't run into, issues of which Laura do we mean? Which Alice do we mean, right? We don't have those clashes because each person will have its unique number that we associate them with. All right, so let's talk about some, how do we design this database? Or how do we actually, write these lines of code that help us create these databases and tables? Let's do this first. So if you would like to follow along, if you're watching NIME live with us right now, feel free to type these commands with me in cs50.dev as we go, or feel free to just watch it and then do it on your own later. But the first thing that we're going to do is open cs50.dev and then create a new database, friendsdb. So I'm going to go to cs50.dev. I'm going to cd in my friends directory that I pre-made, and I'm going to create a new database called friends.db. And it's going to ask if you're sure, and you just click Y, and it already prompts you into the SQL environment where we can write all the other commands. Well, how do we actually create these tables? We need to think about the requirements that we want to have, right? Like, every table will be different. Every table stores different kinds of information. So we need to think ahead of time how we want to structure this database. For example, in this case, I'd like to create a table called friends with at least two columns, ID and name, and at least one additional friend attribute we'd like to store, for example, last name. And it's important to denote ID as the primary key. And syntax for SQL is a little different, right, from what we saw before. It's not your classic, let's write a program top to bottom structure that we were used to with both C and Python. It's a query-based language. So you can imagine, like, putting some, I really like associating SQL with like Lego. It's like putting some building blocks together and then like combining it into one thing. So if we wanted to create a table inside our database, this is how we might want to go about it. So note that the words that are capitalized, in this case, create table and primary key, is the SQL keywords, right? And that is the convention to capitalize all of the SQL keywords, and then your column names or the values that you'd like to input would be lowercase. So here we are going to create a table called friend. And then inside of the parentheses, we're specifying the columns that we would like to see in this table. For example, in this case, it is ID, first name, last name. And in the end, we're specifying that the ID would be the primary key. And what the primary key does, it ensures that the IDs are going to be unique for every row that you input. And we'll see an example of how it actually is managed. And also, if I'm trying to insert a value, but I'm not specifying a particular ID, my computer will know to create it automatically. And so if I'm just inputting some rows, inputting some values, and I'm not specifying their IDs, they will just be incremented by one as we go. Okay, but what are we missing here? Probably if I ran this right now in my environment, it would work, but how could we improve what we have here right now? What are some additions we can make here? Okay, that's okay. Yeah, so the type. So we can specify types of these columns, right? So I know that the ID should be a number, right, or an integer, and then first name and last name are strings or text in SQL in this case. So we can specify the types, and we can also specify the sort of like the restrictions, right? So I want to make sure that for each of my entries, I have an ID. I have the first name, I have the last name. I don't want to have, you know, like friends whose last name I don't know or whose first name I don't know. So these are all the attributes, so to say, that you can specify before you start working with your database when you create the table in the very beginning. So let's go back to CS50.dev and let's create this table that we just saw on the slides. So I'm going to say create table, and I'm capitalizing the SQL keywords. I'm going to call it friend. And then inside of it, I'm going to specify column ID that is of type integer, and that is not null. So to say, I require it to be, it can't be empty. Second column, first name of type text, that also is required. And then the last column, last name, also text, also not null. And then lastly, specifying that the primary key, in this case, is the ID column, parentheses, parentheses, semicolon, click enter, okay, no error. And let's run schema, which is a very powerful keyword, right, to see the structure of your tables. And here on the bottom, let me get out of the way, we see the schema of our table that we just created. Okay. Okay. What questions do we have so far about SQL, the table that we just created, designing databases? And I can go back to the slides where it's a little bit more visible. Yeah, good question. So in our terminal, we just saw create table if not exists. So that's just like a keyword that SQL uses so that if the table does exist, it's not going to create it again. But if it doesn't, it's going to create us again one more time. Okay, let's keep moving, and maybe let's talk about inserting information into our database, right? So let's go back to CS50.dev and try to insert some values and then show some cases that we can have here. So I'm going to just clear my terminal so that it's a clean start. And then say that I would like to just insert one row of information. And let me actually go back to the slides because I realize I have a little template here. But the syntax, again, is like slightly different. And we will see throughout this section that sort of like for every step that you're trying to take, creating, inserting, selecting, or deleting, there's a specific sequence that you need to follow. So when you want to insert some values or rows into your database, you need to specify the following things. First, the table name, where you would like to insert those values. In this case, it would be friend. And then specifying the column names. So in this case, it would be like ID, first name and last name. And then the second part is the values that you'd like to insert. And it's important that they correlate exactly with the columns that you inputted earlier. So making sure that if column 1 is first name, then my value 1 is the first name of my friend, right? And then value 2 correlates with column 2, maybe in this case, last name. So let's go back to CS50.dev and let's try inserting some values. So for example, let me insert into friends, or I think friend, columns first name and last name. I'm going to insert values Carter, Zenki. Oh, okay. I hate when that happens. It's going to prompt me. Let me kill the terminal and restart again because it will keep me prompting. Okay. So let me cd into friends one more time. And then I'm going to write SQLite 3 friends.db. Okay, perfect. So let me run schema just one more time to remind myself what I have in here. So table friend, perfect. So insert into friend, specifying the columns, so first name, last name, and then values, in this case, Carter, and last name, Zenki, semicolon. And now semicolons are back, unfortunately, which is a little bit annoying, but you really need to make sure that you're not forgetting about those because otherwise the query is not going to run. And let's cross our fingers and hit enter. Okay, we're not seeing anything, right? But we can do select all from friend, and that should hopefully show us Carter's name. And note that I didn't specify the ID directly, right? I didn't say insert into friend ID and then values 1, but because I specified it as a primary key, my ID is automatically populated and it will be incremented. For example, if I run this query again, but maybe adding David as my friend, again, not specifying the ID, hit enter, select again. Now I see 2 entries in my terminal, both for Carter and for David, and their IDs are like automatically incremented by 1, so I don't need to keep specifying that. But could we specify specific IDs? Like, no, I want this person to be ID 5, for example. Let's try to do that as well. So let me just go back to the query we had before, and I'm going to add column ID to the set of values I'd like to change, maybe changing David to John Harvard. Okay. And then adding ID 5. Hit enter. Again, it's not giving me an error, right? Because there's nothing wrong with specifying the ID. And then if I select all of them again, I see that Carter's in there, David is in there, and then John has ID 5 because that is what I wanted to specify on this line right here when I was inserting them into the table. But what happens if, for example, I accidentally type the same ID for a different person, right? Or I forget that there's already a person with ID 5 that exists. Well, let's try testing it. So if I wanted maybe now insert Brian as my friend, and I completely forgot that I already gave John Harvard ID 5, so I'm gonna keep this, and then if I run it, I will see the error, right? Because the ID must be unique. So if you accidentally try to give the same ID to different people, that will not work. But now if I try to give Brian ID 6, and then I select all one more time, I now see all of them outputted in my terminal. Okay, so that was about creating the databases and then inserting some values. And I'm going to take a pause here and ask what questions do we have about this part so far. And I'm going to go through the chat. I already saw there was some there. Okay. Yeah, so someone said, does that mean that each column needs to have unique values or only the primary key? So you can specify if you want other columns to be unique as well by using that unique constraint in the same way that we did with not null, but sort of like when you specify primary key, the unique constraint is already like baked into it, so to say. So you don't have to say, okay, it has to be the primary key and it has to be unique. Like your computer will know that a primary key must be unique by default. Okay. So will the next ID be assigned automatically after giving a specific ID? That's a great question. We can test it. So maybe if I delete 6 and let's find some other name, for example, Alice, I don't know, Smith. And then let's get rid of the ID column right here. And then let's select one more time. Yeah, so the next ID will be based on the row going right before it. So our previous row was 6. So now if we're trying to insert Alice into our database and we're not specifying a specific ID for them, it will just be based off the most previous row in the database, okay? All right, any other questions about this part so far? All right, seeing none, so let's keep going, and we're going to jump right into the first problem set in this week called songs, and we'll get really a lot of practice with it. So the way that this database looks like, we have songs.db, and in it we have 2 tables. The first one called songs, where we have ID column, and as we just learned, that's just unique ID associated with that row. We're going to have a name of the song, and then some attributes that that song has. For example, tempo and duration, as well as the artist ID, right? We want to make sure we can track what singer the specific song belongs to. And then in the second table called artists, we have, again, the ID column that just gives us that unique identifier, the name of the artist, their birth year, as well as label that they belong to. So that is the structure of our database. And we can also go back to CS50.dev, and let me just move into the songs directory. And let's see the schema for this database. So there are actually a lot more other attributes that we have beyond the ones that are described on the slides, but still 2 tables was the key information that we have in there. just some other attributes that we have inside of the database. But let's consider some queries that we can use here, right? And let's talk about selecting first. So this is something that we just did, right? Just using select star from specific table. But there are other sort of constraints that we can set and specific values that we can grab. So for example, if I was looking to grab names of the songs that had duration less than 240, this is how I might go about it, right? And as we just talked a couple of minutes ago, every sort of like set of actions that you'd like to do has a specific order to it. So in select queries, what we specify first is the keyword select itself, which just means that we want to grab those values, right? We want to grab that column. So in this case, we're interested in names. And again, I can always pull up schema side by side and always reference it, making sure that I am using the exact words and the exact names that I have in my database. After selecting the specific column comes the table that you want to grab it from, right? I need to specify exactly the table that I want to look into, even if there's just one table in the database. So select column name from table. And then after that goes all of the restrictions or specific constraints that you'd like to put on that query. In this case, I'm looking specifically for songs that have duration less than 240 seconds. So this is kind of just like, again, building blocks, like, right, consider them Legos. And then if you start with select column name from table, after that, you can add more and more layers. So in this case, what would happen is I would just get, I would look at the second row that we have in this column because I'm interested in the duration that would be less than 240, but what I would actually see in my terminal is just the name of the song Drive, because that is the only column that I selected in my query. Well, what are some other constraints that we can set here? The other one is like. So using the like keyword and the percentage symbol will indicate the wildcard characters and relative location of a string. So for example, if I'm looking for all the titles that have Percy Jackson in the end, I might want to set my wildcard character in the beginning, or if it's reversed, it will be in the end, or if it's somewhere in between, it can be in the middle. And again, this is a non-exhaustive list of all of the keywords and constraints that you can set, and there are definitely a lot more than exists online, and you really just get practice with them and getting intuition of which ones fit where. But let's consider the first query that we want to write for our songs problem set. So for the first SQL file, we want to list the names of all songs in the database. Okay, so maybe let me go back to our schema. And if you want to type in the chat, how would I go about selecting all the song names in my database? How might I go about that? Yeah, exactly. It is really quite simple this time, right? Just select name from songs, because we just want to see all of the songs that we have in the database. And in fact, let's go back to CS50.dev and let's try running it. So select name from songs, semicolon, hit enter. And now we see all of the names that we have in this table. And more precisely, these are top 100 songs from Spotify from 2018. So that's what we are working with today. Well, that's just not as interesting, right? Like I can just like visually even pull up the file and look into all of the names of all of the songs. So what other things can we do? And one of them is ordering. So there's a very powerful keyword called order by, and that is equivalent to your, the sort that you click when you use Google Sheets or you use Excel. That does it automatically by you. And here too, sort of the computer handles it for you, but you just need to specify the keyword as well at the specific column that you'd like to filter by. And in fact, order by is by default ascending. So if you would like your values to be in an increasing order, you don't need to specify anything else. But if you want it to be in descending order, so decreasing values as you go, you do need to specify that keyword as well. And there's, no harm if you want to specify ascending as well. I always forget which one is default, which one's not. So I always put it, just for good measure. But ascending is indeed a default. So in our second query, if we wanted to list the names of all songs in increasing order of tempo, how might we want to go about that? Yeah, exactly. So select name from songs, order by tempo. Exactly right. So the first two lines, select and from, will always sort of be the same. And then after that, you're adding the layers of what you'd like to filter by. And let's actually go here and then try running it. So let me do select name, comma tempo, just so that we can see those filtered or sorted values from songs, order by tempo. And I can indeed see that if we order by tempo and we don't specify in what order, they're in increasing order, so going from the smallest value to the highest. But if I instead did specify descending order, I will see the values go in the opposite direction from the highest to the smallest. Let me remove myself from the screen for a second. So specifying in what order I'd like them to go. Okay, so that was an ordering, right? Another layer that we can use. What about if I just wanted to see some specific values, right? Like I don't want to see, in this case it's just 100 rows, so it's not that bad if you need to scroll through all of them. But if there are like thousands and like tens of thousands of rows, like that's a lot of values that will be in my terminal. So I want to make sure I can just see the specific rows that I want to see instead of seeing all of the ones that I have in the database. And for that, limiting or the limit keyword would be really useful. So in this case, what I would have is select start, which is just like everything, right? Like I will see all of the rows, again, specifying the table that I want to pull this information from. I'd like to see the tempo that's higher than 100 and then ordering by tempo as well. So something that we just saw, right? But I want to limit it to 1, right? Just see the row where my song was the tempo higher than 100. And since we're ordering by ascending, that should be sort of like the lowest of the subset that we see in the database. And in fact, let's try and go running it. So if I do select from songs where tempo is greater than 100, and I'm going to do order by tempo in ascending, and I'm not going to specify limit just yet, but that is indeed just a lot of rows that are not very well organized. So maybe let's just grab name and tempo instead. Okay, so that's better. And right, it is just giving me the ones that have the tempo higher than 100 and all the way up to the highest one. But if I wanted to just grab the very top one, I could specify limit 1, and now I just see one row, or sort of like name and tempo. I would put it on the bottom instead of seeing all of those other rows of information. And the next question, right, that I think is very natural is like, well, how do you know how to layer these constraints, right? Like, why could I not go by order and then by limit, or like switch where and limit, etc.? think about it as, again, like how you subsetting this information and in the sequence that would make sense. So if I'm grabbing all of the rows in the very beginning, right, that's the first 2 lines. And then I want to constrain just by the values. So that will give me my first subset, right? Just decreasing the number of rows that I see, period. And then I want to order that by some value, right? So filtering the data, sorting the data in the format that would make sense to me. And then limiting it by 1, we'll just grab the very last, we'll grab the very last row, which is like the final step of the entire process. And even though SQL is a query-based language, you can apply sort of the same top to bottom principles that we learned in C and Python to make sure you're writing queries in exactly in a way that would produce the results that you want to see. But let's consider the next query that we're prompted to write. So we want to list the names of the top 5 longest songs in the descending order of length. So how might we want to go about that? List the names of the top 5 longest songs in descending order of length. Yeah, exactly. So again, first, selecting the column that we want to select from the table where this data is stored, and then setting our constraints. So ordering by duration. Again, cheat code, open the schema side by side, and then reference exactly the columns that you'd like to see. And then limiting it to 5. So again, just going top to bottom, step by step of how you want to subset your information to get the final output. Okay, maybe let's consider the next one. So we want to list the names of any songs that have densibility, energy, and valence, which is just the attributes that we have in the database, with the values greater than 0.75. Okay, how might we want to go about that? Yeah, so good guess in the chat. And that is the structure that we would like to have. But the tricky thing about SQL is that you literally have to specify every single sort of like column that you'd like to filter by. So again, like the comma separation makes total sense, but just following the syntax of SQL and how we need to structure things in here, you sort of like need to specify that densibility has to be greater than 0.75 and energy and valence, and that will yield the results that would like to see. And let's go back to Sesion.dev and just try running it together. And I'm just going to select all 4 columns just so that we can indeed see that we're grabbing only the songs with the attributes that we want from songs where danceability is greater than 0.75 and energy is greater than 0.75 and valence is greater than 0.75. Hit enter. Ugh, misspelled it. Okay. What is it supposed to be then? Okay, let's try running schema and see where I made a mistake. Okay, that's what I thought I typed. Danceability. Oh, where? I'm looking at the wrong thing. I thought it misspelled densibility. Okay, here we go. Yay. So now we see all the rows where densibility, energy, and valence are all greater than 75. So you're not going to see the other songs that don't have the same they don't have the values greater than that. And someone in the chat asked if there's an operation or. Yes, there is. And so it's used again in the same way. So if you're specifying sort of like multiple constraints in your where clause, so in this case, we were interested in both sensibility and energy and valence, so we use the and operator. But if you just want to use or, that is an option as well. And you can, again, just write them one after another after you put the where clause once. Well, this has just been, so far just like outputting the information that we have in the database, or like the name, or like some other columns. But what if I wanted to have, some statistics, right? Some metrics that I'd like to consider? Well, that would be the aggregating functions. And there are a couple of them that exist. And the ones that we will see today is count and average. But essentially, what these functions do is count will just count the number of rows after you did all of your operations and constraints. Min and max can grab those minimal and maximal values. Average would average the values in a specific column. So we can see an example in just a second. And then sum, sort of like the similar one where you're just like summing up all of those values. And especially for the one that deals with the numerical values, right, we'll only be able to use them on the respective columns, respective type. But if I wanted to count the number of songs where the tempo is 100, this is how I might go about it. And it is a little weird, right? Because it's like select and count, like right after another. But we're still sort of like selecting everything from songs where tempo is greater than 100. And then you can think about count as being the last layer that you put on. So it's almost like outputting all of the rows with the tempo greater than 100, and then going in and counting them, and that is exactly the value that we would see in the end. And in fact, let's go back to co2.dev and try running this. So select count star from songs where tempo is greater than 100, semicolon, right? And I just see one output, right? I don't see all of the 65 rows. I just see one value. And if you didn't want to see, like count star as the title of your column, one trick that you could use is specifying the name. So you can use another keyword as, for example, n, run it, and then instead of count star, we can specify the other name of the column that you'd like to see. Okay, so what other aggregating functions are there? There is average, which will just give you the average value of the tempo in this case. But let's consider another query is how do we find an average energy of all songs, right? How do we do that? If you want to type your answer in the chat. How might we go about this query? So if we want to find, so select average energy from songs and just being careful with the keywords, right? So AFG stands for average, and that is how we can find the average energy in all of our songs, right? Because we didn't specify any other constraints in the songs table. So before we keep moving, let me pause here and ask what other questions do we have about what have we talked about? Selecting, aggregating, limiting, ordering. What questions do we have about that so far? How's white spaces handled in SQL? That's a great question. So if you are looking for specific values that have white spaces, you can always use quotes. And then I think in the lecture, Professor Malin gave an example of what happens if you have a quote inside of the string. So that would be a good resource to go back to. Someone asked, can you nest and or in parentheses? You can definitely play around, with using both at the same time, which could also be helpful depending on what kind of output you're looking for. Yeah, so someone asked about the limit operator and how we can filter pages on some web pages. So that definitely goes maybe like even the next week, week 8, where we're talking about HTML, and then week 9 where we're talking about Flask. So that would definitely require some more engineering of how you'd like to combine those things together. I would say that if you're talking about web pages, that would have to do more with how you display things on the web page, and there are different elements that will help you control that as well. But let me keep going and let's talk about a few other things, right? So far we've only considered one table, so we've been working with the table songs, but very often you will have multiple tables, right? And you'll have these relationships that you would like to combine together. So how might we want to go about that? Well, especially today we're going to talk about two different things. So one option is nested selects, which is my personal favorite, but it might not make the most sense to all the people. So there are also joins, and we're going to touch on both. So talking about nested selects first, let's consider this, the table that we saw previously, right? And this is where our connection is. So artists have their own IDs, and then so do songs, but where they connect is on artist ID. So we can see that, especially as humans, right, visually, I can say, okay, something comforting was written, sung by an artist was ID 23. I visually go into the artist table and I see it as Porter Robinson, right? But computers don't make like the same visual connections as us. So there's some extra steps that we might want to do here. Well, let's consider a case where I want to select all the songs that were written by an artist named O Wonder. So this is how I might want to structure my query, and we'll go through it one by one. So the first thing that I want to make sure I have is the ID of O Wonder, right? Because that is my connection. That is where I will trace sort of with an arrow where I'd like to go in songs. So you almost want to consider the most inner query first, because that is where we're going to begin. So if I'm selecting ID from artist where name is O Wonder, I will get 45 back, right? Just that one specific number. And maybe if I was copy pasting, I could do something like, okay, we'll just select this all the rows from table songs where artist ID is equal 45, right? But that would require me writing two separate queries, remembering number 45. But this is sort of like the underlying steps of what is going on. And so once that 45 is returned after I ran the previous query, I will get the entire row in the column songs. But again, I'm not like writing 45, I'm not hard coding it. I'm really creating these relationships between the two tables by knowing that the artist ID in the songs table and the ID in the artist table is where these two tables connect. So I can use that to write my nested select statements. And yeah, it is sort of 45 that we're ultimately looking into, but we're not hard coding that. We're instead writing a query to find that value. And similarly with joins, right? Recall that I was just saying, like connect and relate to. So join sort of like anchors on the same idea of where do these two tables connect. And so once again, it is the artist ID table, the artist ID column in the songs table, and then the ID column in artists table. And if we use the join statement, we're literally just creating this one big table where I'm saying table so many times, where two other tables are combined into one, and now we can sort of like easily track one another. And the natural question to ask, right, like where is one better than the other? And at least for the purposes of the problems in CS50, it really doesn't matter. I like nested selects because it just makes more sense to me to build blocks like that. Some people really like joins. But one thing to consider is you don't want to over join some tables because they do kind of like almost double in space because they take up so much memory that if there is an easier way to just do a nested select or even just cross-referencing it, avoiding too many joins is definitely best. But how would that look like in code? Well, this is the query that we might want to write if you just want to connect the two tables, right? So again, selecting and from is what we already know, what we already had practice with. And then the new part is join. So note that I'm not saying join artists and songs because I'm selecting something from songs. So computer solver already knows, okay, I'm working with the songs table. And I'm telling it, well, join artists. So now it has these two tables side by side in memory. And then I'm telling it, join it on these two columns. So songs.artistid and artist.id, because I know as like a programmer, right, this is where my two tables connect. And so ultimately, this is what the output will be, right? Two tables connected together based on those columns. And then after I did my join, I could specify what I am looking for by using the where keyword and specifying the artist name. And know that we're using this like dot notation to say, okay, I want this specific table, songs or artists, and a specific column in it. So artist.name or songs.artistid, etc. So we'll yield the same results as the nested selects, just like slightly different process, but same idea of thinking where do these tables connect, like right, what columns can we cross-reference to establish this relationship. Okay, so let me take a pause here and ask what questions we have so far, and in just a second after this, we'll see some examples too. So if you want to hold off on questions, that's also fine. So someone said the ID column sort of like doubled. Is there a way to delete one of the ID columns? Well, note that this is not, we're not sort of storing this table. This is something that created just temporarily after we ran that query. So actually, if I hit enter, right, I do get that information in the terminal, but this joined table is not necessarily stored somewhere. It was just created temporarily so that I, as a user or programmer, can access those values, but we're not necessarily storing it anywhere after this. Okay. Okay, let's see some examples, and I'm sure we'll have more questions after this, but let's consider the sixth query where we want to list the names of the songs that are by Post Malone. How might we want to go about that? So, some ways to do it. We just talked about, so a couple of ways we can grab these values. Any ideas? I hear people typing, so I'm going to give it a couple more seconds. Okay, so this is how we might want to go about it, right? So in this case, maybe nested selects would be a way to go. So again, thinking about it inside out. So the first thing that we want to do is, again, think about the connection that these two tables have. And we know it's artist ID and ID. And so what we want to grab first is the ID of Post Malone, right? Like thinking back to the example with Oh Wonder where we get the ID 45, so similar idea here. So the nested select query will return us some number, for example, like 22. And then after that, the most outer query will run select name from songs where artist ID equal to the specific ID. And we as humans don't see those numbers, but that is sort of like the sequence of operations that is going on under the hood. Okay. So maybe let's try running some of them here. And let's do it step by step, sort of like how computer might do it. So let's first select ID from artists, where name is equal to Post Malone. Oh, typo. Name. Okay, so ID is 54, right? And I could have done something like select name from songs where artist ID is equal 54. And I will see their songs, but I could also be, like smarter about it and have better design. So instead of hard coding 54, which might not be 54 in some other database, right? I want to make sure I'm not leaving these things up to error. I'm going to select ID from artists, where name is equal to Post Malone. And I get exact same output again by just sort of referencing it instead of hard coding it, okay? So let's consider another one where we want to find the average energy of songs that are by Drake, right? Adding even more layers. So how do you want to go about that? Right, again, thinking sort of like innermost to outermost. First, we would like to find Drake's ID, right, to make sure that we have that reference. And then after that, we want to use our aggregate function to find the average energy. So this, I'm going to give it maybe like 10 more seconds in case people want to think about it a little bit more. I know it's a lot to type out in the chat. So, okay, maybe you already thought about it, but this is how you might want to go about it. So again, select and from our best friends. So that's the keywords we're using. And then let's sort of jump to the very end again and consider the most inner select keyword. So we're selecting ID from artists where name equals Drake. And again, that will give us some number. That is Drake's ID. And then after that, we are going back to our outer select statement where we're using an aggregate function called average to find the average energy of Drake's songs and by referencing their artist ID. So again, let's go back to CS50.dev and see how we can do that in practice. So let's go through the same exercise of selecting Drake's ID first. So select ID from artists where name is equal Drake. Okay, so that would be 23. And even right now, as we're thinking through all of these examples, this is a good way to start, right? Don't write the entire, like 5 nested selects, like all together. Start one by one, thinking about, okay, what do I need to grab first? What is the next step? Creating these select queries one by one instead of just like dumping it all in the terminal and then, not really understanding what's going on. So my first step is getting ID of the Drake because this is how I will relate my 2 tables. And so after I have that ID, it's a little bit easier to calculate the energy. So select average energy from songs where artist ID is equal to select ID from artists where name is equal to Drake. Okay. Hopefully no typos. And see here we have just one row of information after that entire query, but that's what we're looking for, right? We just want to consider the average energy of all the songs where Drake is a performer. And let's actually sort of like unwrap it to the previous layer, right? It didn't get to the average part right away. So let's see what would happen if we just had the energy outputted, and this is what we would see, right? So maybe all of the songs by Drake, we first see just the column with all of these values, but then by using the average function, we can minimize it to just one value that we're interested in. And I'm seeing some questions in the chat pop in. So let me just scroll through them. Okay. Yeah, so there are different ways to do it, right? So for example, here I used an equal sign. On the slides, we used the in keyword, which would work fine, right? Because in this case, select ID from artist where name is equal to Drake will just yield one ID. But as you recall from the lecture, in would look for, right, if we, instead of just one value from this nested select, we had multiple ones, it could also just look for that instead of having like the direct equal relationship. Okay, and let's jump to the very last query that we need to write for the songs problem set, and it's a little unrelated to the joins and the selects that we just talked about, but goes back to our wildcard and like operator. So, and this is a little tricky, and you might not know it without looking at the whole data first. So let's do this. Let's just select all names from songs. Okay, and let's look for that. So our goal is to list the names of the songs that feature other artists. And if you're not familiar, the way that we can track that is by looking for this specific keyword. So FEAT dot. So this is a really good tell if someone is featured on the song, but as you can see, right, there can be some other words before it, some other words after it. So the wildcard and the like operator is really powerful here. And I already see some suggestions in the chat, and this is how we might want to go about it, right? So again, the select and the from will stay there. And then instead of specifying, where a name equals something, we're using the like operator. We're not entirely sure how it might look like, but we can guess that the FEAT period will be somewhere in between. And therefore, we're using percent signs on both sides because there might be some words that come before it, some words that come after it. And so we're just looking for that keyword in between. So let's go back to our terminal and try running this command using quotes and then percent signs inside of it. Oh, I didn't specify what column I'm looking for. So now we see the list of all the names of the songs where some other artists are featured. And again, I wouldn't know that this is exactly what I'm looking for without just like inspecting my database at first, right? I might just look through some of the entries in the table and then find some patterns that can be helpful for me to use as I'm querying for something. And I have a little cheat sheet right here that I just pre-made before, but this is how you might want to go about it, right? It's totally okay to not knowing exactly what query you want to write from the very beginning, right? It's sort of similar to pseudocoding as we did before, right? Writing out some ideas and then trying to put these building blocks together to get the query that you want in the end. And this was certainly a non-exhaustive list of all the SQL keywords there are, all the different operators and things you can do with it. Again, they sort of like don't come like baked into your brain, so feel free to browse around. W3 Schools is a really great resource to finding those SQL keywords that we might not show in the lecture. And practice would be your best friend as well as you're getting used to the query-based language. But this was it for today. This was week 7. Thank you so much for joining, and we'll see you next time. Bye, everyone.